Hello and welcome to Lesson 11 of Software Design and Development for Higher Computing Science. Today we're going to convert characters to ASCII and vice versa. In programming, you know you can store words. These are called strings. There's a string. You can store numbers, and there are different types of numbers. There's an integer, and there's a float. You can store booleans, which are either true or false. And you've got things called arrays, which are multiple things. There's an array of integers. You've also learned about records, and there are a couple of other data types that you haven't learned of. But today you're going to be reminded of a character. So a character is kind of like a string, but it only has a length of 1. So a single character, whether it's text, numbers, or a special character. Now you'll also remember from National 5 that computers store text using a thing called a character map. The character map you learned of was ASCII, American Standard Code for Information Interchange. So this is just like a big table that has all the characters, and there are numbers next to those characters so that the computer knows when it receives a binary number, it can figure out which character that number refers to. So we can find the ASCII value of a character using the ORD function. So we can give it the character, and it will calculate the value based on that character. Let's print the value of our character. Now the character A, uppercase A, has a value of 65. Uppercase B has a value of 66. And C has a value of 67. There we go. Can you guess what Z has? 90. So you can see that all the uppercase characters are in a row. They're all next to each other, from 65 up to 90. We can use that information. The same is true of lowercase letters. Lowercase a is 97 and lowercase z is 122. There we go. And it's also true of numbers. The character 0 starts at 48 and it goes all the way through 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 57. So with that in mind, we can check this. We can use the value of a character entered by the user to see what type of character it is. Let's do that. Let's ask the user to input a character, and let's check if it's a number, uppercase, or lowercase. So let's say if the ASCII value of the character is greater than or equal to the ASCII value of uppercase A, and the ASCII value of the character is less than or equal to the ASCII value of uppercase Z, then we can print, you entered an uppercase letter. Now if they didn't enter an uppercase letter, we can check for something else. So let's copy this and paste it below, but we'll say elif to join these together. And instead of uppercase, we'll do lowercase. And we'll do the same again, but this time for the numbers. So we'll do elif, and we'll check if it's greater than or equal to the 0 or less than or equal to the 9. And that is a number. Let's run this, see if it works. Enter a character, D. You entered a lowercase letter. Excellent, because the ASCII value of D is greater than or equal to the ASCII value of A, and it's less than or equal to the ASCII value of Z. Let's try it again. 5. You entered a number. Nice one. What about uppercase? Does it work? Excellent, it works. What about special characters? It says nothing. Well, we could just type an else and print, you entered a special character. Let's try it now. Woo! It's working. I love it. So this is one example, but it's not very realistic. You're not going to ask a user to type in one character and then say what it was that they typed in. But what might be more realistic is if you're asking the user to enter a username, enter your username, and we want to check if it contains any numbers and tell them that that's not a valid username, we can do that. Let's give it a go. Now, if we're going to check every character in this username, we need to know if it's a valid username by seeing whether or not there are numbers present. So let's create a variable called valid, and let's set it to equal to true. We're just going to assume that the username is valid unless we find a number in there. And what we'll do is for every character in the username, we'll check if that ASCII value of that character is greater than or equal to the ASCII value of 0, and if the ASCII value of that character is less than or equal to the ASCII value of 9. So what this means is that this character, whichever one we're looking at, is a number. So if there is a number, we can say valid equals false. So if we get all the way through the username and there are no numbers, that means that valid will still be true. So that means it doesn't contain any numbers. So if we get out the loop, we can say if valid equals true. Now I don't actually need to check if it equals true, because what if statements do is they just check if the following condition turns out to be true. If it evaluates as true, then we execute what is inside the if statement. Well, if valid is true, then it evaluates as true. So we don't need to check if it equals true, because if it's true, it equals true. Hope that makes sense. So if the password is valid, we can print something like, thanks, that's a valid username. Otherwise, we could print something like, nah, that username contains numbers. Something along these lines. Let's give it a blast. So my username is computing, but I'm using a 1 instead of an I, because I'm edgy. Oh no, it contains numbers. I can't have that. All right, let's try it without any numbers. Woo, that's a valid username. So this is just one example of how to convert characters to ASCII. But what about the vice versa, converting ASCII values to characters? Well, we use a different function. Let's say we have a value, 122, and we want to find the character that that represents. We use the chr function. We give it the value, and then we can print the character. Z. Oh yes, and you may remember that that's what that was. So how could we use this? Well, one example could be if you were creating a thing called a Caesar's cipher. This was a very simple encryption method, and all it does is it takes the alphabet, and for the message being delivered, all they would do is shift each letter up the alphabet depending on the certain key. So if the key was 5, for example, this H would become something else. It would move up from H, 1, 2, 3, 4, 5 to M. So the new message would start with M, and then the E would go up 5, 1, 2, 3, 4, 5. That would be a J. And then the two L's would be converted to Q's. And the O would become a T. So instead of seeing hello, the recipient would see MJQQT, but then they would have to shift each of these characters down 5 to convert it back into the original message. This is called the Caesar cipher. Very simple, but it's a good way of understanding encryption, converting a message into a kind of a scrambled version that can then be decoded for the recipient. Well, we can create the Caesar cipher. Let's get a message from the user, and let's get the key as well. And the key is an integer. What we can do is, we can create a new message that is blank initially, but we're going to append each new character to it. But we're going to shift each character and append it to the new message. So for car in message, new message equals new message plus, so this is how we append the new characters. And what we're going to do is we're going to find the character that has an ASCII value of that character plus the key. So for each character in the message, we find the ASCII value of it, we add the key to it, and then we convert that new number into a character and add it to the message. Then at the end, we just print the new message. Let's give it a blast. Enter your message, hello, enter your key, 5, MJQQT. What a beast. Now let's say you receive a message, MJQQT. What you can do to decrypt it, MJQQT, is type -5 as the key. And it converts it back to the character. Not bad, eh? So this is one example of why you would convert characters to ASCII and ASCII to characters. Hope you've enjoyed this lesson, hope you've learned a lot. Have an experiment with it, see if you can make a Caesar cipher that makes it a bit better than this. Because this one isn't the best. Hope you've enjoyed this one, I'll see you in the next one.